So 1 by root 2 times. So 1 by root 2 times will be 0.7, or a by root 2, I'll write it. So the particle which is here will be like this. Okay, see now. So this is the thing like this. So this is the angle theta. So what is the distance? This will be a by root 2, and this is it. We know this particular time. How much of it is like it? 2 milliseconds the particle will take to move from mean position to a by root 2 times of maximum displacement. Okay, now you go back to this one. So what is theta? Theta, we can write it as theta equal to pi by 4 radian. Then for angular displacement of theta, it will take time t. For an angular displacement of 2 pi radian, it will take time 2 pi. So this will be pi by 4, 2 into 10 to the power of minus 3, 2 pi by t. I think 16 milliseconds. 2 to the 4, 4. Yeah. Milliseconds. Huh? There's a time taken to complete one oscillation. Correct, no? Okay, let me check once. So this will be pi by 4, 8, 8. This will be 16 milliseconds is what time taken. Okay, there's one oscillation. Okay, now we know time period. So with this, what we can calculate, omega equal to 2 pi by t. So 2 pi by 16, or this will be pi by 8 omega. Okay, now what is the other information we have? And the velocity at this position is 20 meter per second. He has given the particle speed Vp equal to. So what is Vp equal to? 20 meter per second. Okay, now with the help of this, Vp equal to omega root of a square minus y square. We know particle speed, we know omega, we know y also, a by root 2. With that, what happened? We'll get the amplitude. So this, I'll write it.
Sir, the time is in millisecond, no, sir. So omega will be different.
Oh, I didn't write it, no? Wait. 16 into 10 to the power of minus 3. 1000 by 8. 1000 pi by 8. Anybody value of this?
One 125.
Okay, no. Now, what is y? This is what y? V equal to omega omega, this will be a square minus a square by 2. Omega a, this will be 1 by root 2. So we know omega, we know p, from that we'll get the amplitude. So what is the amplitude? Amplitude will be root 2. Are you getting, very beautifully the question was being framed by me only, not I didn't copy anywhere. I just wanted like students to, because students, the moment wavelengths or no, they'll start thinking about some other formula. Is testing the SHM ideas a little bit here. Okay, we'll get the amplitude. Huh? Okay, after getting the amplitude, we know omega. I want the wave speed. It's telling the phase difference is pi by 4 of particles separated by 0.2 meter. So what is the formula? 2 pi by lambda into delta x. Now you can ask question like, sir, how you brought this equation? The phase difference between two particles which are separated by distance is given by this one. Let me first take it out. So let me go for a general view. Yeah, it's a very simple. You need not to struggle much here. In general, okay, if you have this is y-x graph, then the wave, let's assume the wave is moving towards right. Okay, based on this, so can we predict the direction in which the particles are moving? So they should be moving down. I think now we are in far better position. We can directly say that the points on a rope, they are moving. Now you define one wavelength, distance between 2 points on a rope which will have same phase. How you say same phase? The particle must have the same velocity. They are said to be same phase. Look at these 2 points here. So they're having a same phase here because both are at mean position and both are moving down. Then we'll define that as lambda. No, can you remember? I think this was the rule what we made here. Now, shall I ask you what is the phase difference between these two? So what is the phase difference between them? Will be 2 pi on this one. So how you can say 2 pi here? So that the formula what we have is pi is equal to 2 pi lambda into delta x. You can check it. If I take the phase of this is to be 0, the phase of this should be 2 pi. On what basis? What is the separation between these two particles? Is a lambda. Substitute here delta x lambda. Then you'll get the phase difference 2 pi. What is the phase difference between these two particles? What is the separation? This will be lambda by 2. What is the separation between these two? Lambda by 4. So now, can we calculate the phase difference between any 2 points when a wave is propagating on a rope? Yes, that one. So what is the phase difference between any 2 points on a rope? There's a generalized formula what I'll use here. Now, what is the phase difference between particles? Let me give a number. There's a 1, there's a 2, 3. I'm interested in this one. So what is the phase difference between 1, 2, between particles 1, 2? I'll use formula 2 pi by lambda. What is the separation? Lambda by 4. So this will become pi by 2. I think we are very clear, no? We know SHM. If particle is at extreme, other particle is at mean. What is the phase difference between them? Should be pi by 2. We know SHM. Go back to SHM. Similarly, what is the phase difference between 1 and 3? Now I'll take it out. I'll write it here somewhere. This is the important formula. So no phase difference between 1, 3. So 2 pi by lambda. What is the difference between 1 and 3? The horizontal separation. So this will be pi. I think we know if the particles move opposite to each other, what is the phase angle? Should be pi radian. What is the phase angle between 1 and 4? That also will check it. 3 lambda by 4. So this will become 3 pi by 2. The phase difference between 1 and 5. So like this, using this formula, what you can do, you can find out the phase difference between any 2 points on a rope. We can find out phase difference on a string separated by a distance delta x. Okay, there's a very important formula like this. The numericals will be tested. Yeah, okay. Between any 2 points, on a string separated. Okay, fine. So this is something, the data. Let me share this also. Very, 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 very important. So many concepts next coming chapters. No, I'll be using this small elemental, small data. I'm just putting it nearby diagram so that things students can manage very easily. Okay, now let's get into the question. What is asking? What he has given? The phase difference is pi by 4 of particles separated by 0.2 meter. Shall we take help of this data? This is one generalized information. Please do remember. Hmm?
Sir,
Yeah.
sir, phase difference between 1 and 5 is 2 pi, no, sir? In the diagram you gave pi.
2 pi,
Okay,
2
sir,
pi.
okay.
Okay, I'll do one thing. Okay, that. Okay, no.
Yes, sir.
Okay, now shall we go to the calculation? We'll take up of that formula. So now we got some idea. I think I can finish off problem here only. We'll use that formula, the phase angle. No. What is the phase angle given? Pi by 4, 2 pi, lambda. Do we know lambda? I think for that we should know k. How to bring k now? For that we need wave speed, no? Okay, I'll do one thing. I'll come to this. First, let me bring the wave speed. Okay, we know time period. From time period, we know omega. Lambda is needed, no? Separated by 0.2 meter. We know amplitude. We know particle speed. Wave speed is needed, no? A point on a rope takes it 2 million. So we know omega. Omega, okay, then we needed k, no? Okay, now we know particle speed. Particle speed equal to Vp equal to into slope. So do we know slope idea?
Sir, can we take delta x equal to 0.2?
0.2 meter. Delta x, we know it. Okay, from lambda, we'll get from here, no? Then I'll get the wave speed. Sorry. I think, yeah. I'm unable to see that 0.2 meter is available here, no? Not visible. Yeah, okay, no. Into delta x. So we know phase angle, pi by 4, 2 pi lambda 0.2. Anybody lambda value? 1.6 meter. Eight to the 16, 1.6 meter is the lambda. After getting the lambda, yeah, 1.6. After getting lambda, then I'll go for k. Pi will be 0.8, 0.8. This will be 10 by 8, 5 pi by 4. Okay, there's now we know. Okay, now I'll get the wave speed. Okay, anyway, if needed, okay, you can go for it. Huh? Okay, now I got, so what is the wave equation? Now at t equals 0, end of the rope is at mean position and moving downwards. I think I assumed correct one, no? This at t equals 0, I can also write it. The wave is propagating towards right. So therefore, what is the wave equation I should go for now? Y equal to a sine. He has nicely mixed up SHM with waves and sound concept. Do we know amplitude? As we have in the corner there. We know amplitude. We know omega. We know k. Substituting will get the wave equation. And these are very popular things so which a student has to remember. I'll show the complete question. Okay, just any doubt to clarify it. So why the shape of the rope like this only? Next, at t equals 0 is telling a point on a rope. At t equals 0, end of the rope is at mean position and moving downward. I think is it justified? So therefore the wave must propagate in this direction. So therefore put t equals 0. If you draw it, the shape of the rope like this, no? Therefore I am able to assume the equation like this here. Any doubt, please do clarify. Now, what is it? What is it? This is something very important. If you know phase difference between 2 points which are separated by some distance, with that we'll get the wavelength. Getting the idea? Try to make some observation. Between two different points on a rope, not of a single point. 2 points on a rope separated by horizontal distance delta x. So you can predict the phase difference. If you know phase difference between 2 points, and if you know that horizontal separation, not separation like this, horizontal separation, then with that we'll get the wavelength. This is the use of this one. Now, what is this? Like a, say, if the wave propagates a distance lambda, how much of phase it will gain? 2 pi. There's a meaning. The wave is present here. As it propagates a distance lambda, how much of phase it will gain? It will gain a phase of 2 pi radian. If a wave propagates a distance of lambda by 2, how much of phase it will gain? Pi radian. There's a meaning, because as the wave propagates, what happens? It will gain phase. That is what we are trying to express in this particular thing. Okay, let me take you to the next question. Really, students as to